Good evening, everyone. I hope I'm audible to everyone. So let's start this class in about 2 minutes. In the meanwhile, if you're having any friends in this from the session, please ask them to join the session as soon as possible. So in this session, we'll be discussing about the ML models. We'll be having multiple ML models to discuss. So if you look at the screen that is being shared, you can see that we'll be discussing about regression analysis, bivariate, multivariate, linear regression, decision tree regressor, random forest, and other models. Give me some confirmation that my screen is visible to everyone. Okay, we'll be starting the session in about 2 minutes. I hope everyone remembers that we only have 2 sessions left. In the 2 sessions, what we are having, we need to discuss about the Flask and also the Flask deployment that we'll be having in the next session. And in this session, we'll be having a practical about the ML models which I have discussed until now. So we'll have a look at all the regression models that we'll be having. So let's discuss about the first regression models, regression analysis bivariate. So what are the encodings and how to classify, how to visualize, and everything we'll be discussing. So if you're ready, then we'll be starting the session. Give me some confirmation that we can go ahead and start the session right now. I need some confirmation from you guys that we can start the session right now. Okay. So here, whatever you're seeing are the topics which we'll be discussing. So if you look at the screen, so I have already run the cells for regression analysis, bivariate, multivariate, linear regression, dictionary regressor. So coming to random forest regressor, the cells are being currently executed. Now, if you can see here in the bottom, I hope everyone can see where my mouse is pointed. So here, if you're seeing, I've been executing this notebook from the past 36 minutes. So what are the notebook that I'll be executing? This is taking some time. So I'll be telling you why it is taking so much of time for executing. And also we'll go through this part. But first we need to understand the 34 cells, 4 to 28 and 17 cells. So in this, we'll be going with regression analysis, what we'll be doing. So please make sure that we'll be classifying a regression problem. Okay, we'll be handling a machine learning problem that is from regression model. And we'll be performing the problem with what are the regression models that we'll be having. And I want you all to respond in the meanwhile because when I'm explaining code, I want you to respond so that I can understand that you are you are understanding this code. So until now, from what are the things you learned, you heard, and you attended, that didn't matter if you didn't understand and listen to the session which we'll be having right now. So if you're looking at the first cell that we'll be having, the first cell which we're having is importing all the libraries that we'll be using in this in this problem. So the first thing we are doing is importing the ML model, ML algorithms and ML libraries that we'll be having. So our goal is to build a machine learning model that looks at someone's characteristics. So let's understand what is this model is all about. So first, let's go to the data. Let's understand what is the data set we're having. So if you're looking at this data set, you can see now we'll be studying all the linear regression models that we'll be having. Not linear regression, we'll be studying about the models of regression. Not only linear regression, we'll be discussing about decision tree regressor. I hope this doubt was asked by someone in the previous session. So I have included this decision tree regressor in this problem. Okay, we'll be understanding how decision tree regressor is being used for regression problems, and also we'll be having multiple problems. You can see that right now, regression analysis. So these are for the understanding of the problem and everything. So linear regression, decision tree regressor, random forest regression. We'll be having KNN and stacking. Okay. So these are all the topics that we'll be discussing today, not only linear regression. I hope you understood this point. So if you're looking at the data set, please, whenever you're trying to perform some operations on mathematics like machine learning, please understand the math and the categorical values that are present. Yeah, as we are left with the 2 session time, okay, and the only topic that we need to discuss is Flask. Okay, so what I thought was to show you how the machine learning model works and what we'll be doing at certain kind of conditions. So we'll be discussing about all the algorithms that we'll be having, and also I'll explain why we are using these kinds of keywords and this kind of libraries at this kind of at particular situations. So the first thing that you need to do is understand the data set. Whenever you're trying to implement some problem, whether it's a classification or regression, please make sure you understand the data set. Okay, if you're looking at this, the first thing we'll having is age. Okay, these are the age of the so the age data point. This is the gender. So here, if you're seeing, we are having some null values in age. Okay, before going to the problem, also you can when you're looking at the data set, you can understand that the data set is having some null values. Okay, so this will have some understanding that what is your data set is it a clean data set or is it unclean data set? So we are having BMI, classification, children age, I think it is. Okay, so smoker, yes or no, region and changes. Sorry, charges. So this is insurance data, how insurance data works and everything. Now we'll be going to this cell where we are having the analysis for regression, how regression works for that starting away. No, we don't cover any DL topics. This internship is only regarding the machine learning. So that's why we'll be discussing this model and everything. So if you want any DL topics, we can discuss in the last session that is of tomorrow. And also we can discuss that in the project mentoring and the sessions we'll be having from next week onwards. No worries if you're having any doubts regarding DL and everything will be solved by our mentors. And if I'm available, I will be solving your doubts also. So as of the main context that we need to discuss is ML. So we'll be going with the track that we are having right now. So if you want to go further with the track, in the upcoming sessions that we're having, please make sure that you complete your project as soon as possible so that what are the remaining sessions that we're having, we will discuss this real or the next thing that is transformers, GANs, agentic AI, or some other thing in the next session. So the connection with mentors one-on-one, I think it might be possible, but I need to check with my team. So the manpower, what we're having, it needs to be sufficient with the participants that we are occupying every day. So we're having a 40 participants every day, but this is not only the program that we're having. We are having this VIP program with multiple domains. We are having the service now Salesforce, artificial intelligence, Gen AI, and some other things. So we need to check with my team that is it possible or not. No worries, we'll inform in the Telegram group once you ping the message. Okay. I hope all your queries have been solved so that we can directly dive into the technical. So as we have discussed the project details, everything will be discussed from the next week. Okay, because we will be having this project analysis and everything that is going on from next week. So let's wait until this week continue like this weekends and the topic which we'll be discussing ends. So that after that we'll be having this discussion. Guys, give me a minute. I'm checking the calendar right now. I'll inform you everything regarding the points and everything within a minute. The project development that will start on 16th of June. Okay, that is from Monday of next week. And after this, we'll be having a continuous day-to-day session of 2 hours. Until now, we are having alternate sessions, right? So from the next week, we'll be having sessions for every day. Okay, for every day, we'll be having a 2 hour session. So in these sessions, what we're having, we'll be having a product development course. So in this product development, we'll be helping you how to develop a project. And we want you to develop a project. And whenever you're having some errors, we'll be present in the meet to rectify those errors. The code which I'm sharing right now will not be transferred to you because this code is consists of the entire machine learning project. So I request you all to build a project just like the one which I'm showing right now. So the product submission date that might be on 26th of June. So we'll be starting the project on Monday, that is 16th. So from next week we'll be starting the project, and after that we'll be ending the project on Thursday, that is the next week of upcoming week. So we'll be starting on 16th June and we'll be ending on 26th June. So we'll be having a span of 10 days. So I want you all to complete this project in 10 days. And if you're completing the project well before, then we'll be having some sessions. So in the sessions, if you're interested, we can discuss further topics that as you have mentioned, DL, generative AI, transformers, and other topics which are necessary for the students to learn. So I hope I have solved all of your queries. That's great to know someone from this class already knows ML. So please revise your topics whenever I'm explaining these ML topics. And also make sure you understand this project as you already told you know ML. So we'll be diving into this regression analysis. I hope my screen is being visible to everyone. So first, we're importing all the necessary libraries. If you're seeing this NumPy, Pandas, Matplotlib, Seaborn. So coming to the first thing, NumPy is for numerical calculations, numerical Python. So as you understand this, NumPy is used for numerical Python. Coming to other libraries, that is Pandas and Matplotlib. So we'll be having these libraries to install based upon the algorithm, based upon the activities we'll be doing. So Pandas is all known for the data frames that we'll be having. So if you're having multiple data frames, multiple arrays of data, then we'll be using Pandas. And Matplotlib and Seaborn, these are our artists. So these can help to create some beautiful charts and graphs to understand the data better. Coming to scikit-learn, this is a core machine learning library. Okay. So this sklearn is nothing but core machine learning library that we'll be using. This core machine learning library, it provides all the algorithms we'll be using for building our machine learning models and tools for preparing our data. So if you can see here, we can see pre-processing is taken from sklearn, linear model is taken from sklearn, model selection is taken from sklearn, ensemble is taken from sklearn, and also everything that we are doing in ML is taken from the sklearn. Okay. Now here, I will run this again. So this cell is completed. So this cell contains every library that we need to import for my model. Okay, for my model, what I'll be having, I need to import every library that I'm having right now. Okay, coming to the next cell, here I'm taking this data set from my local library. So if you see that, look at the screen. So this content, insurance data project is the path where I'll be having my data. Okay, if you remove this thing, it throws you an error. Okay, so the reason it is showing an error because the path which we have discussed is incorrect. No such file or directory is present in this thing. So what I'll be doing is I'll be removing this thing. I'll be giving the path. Okay, because the three dots, copy the path. Okay. So for that, first I need to go to this upload button. Okay, I need to go to this upload button and I'll be selecting. I'll be selecting the CSV or Excel file that I need for my project. So when I click on this, I'll be clicking on open. When I click on open, this will be uploaded in my Colab notebook. Okay. So once I give the correct path for my cell, then you can see this can print my DF. This is different. So it's completes a Nova series. So it's better to learn both the things. So SNS and PL, like SNS and PLT is mostly used for Matplotlib. So what is the main difference between SNS and Matplotlib that I've already shown you in the previous session where I'll be when I was discussing about this both the libraries. So you can see SNS is mostly used for the diagrams or the variations where you don't need to define the diagram entirely. Suppose if you want to get a visualization, you need to define everything that in the Matplotlib. Matplotlib, you need to define the axis, you need to define the color and everything. But coming to SNS, it should be very useful that it is a less time consumption. First thing, it is a less code. Because what are the things you're discussing, what are the things you're describing also, it doesn't need to have the exact details what you're mentioning in the code. Okay, suppose if you want to create a bar chart, you need to define every color of the bars and also the bar heights and everything. And therefore, you need to define the data points. But coming to SNS, this is a library where you also doesn't have to define everything. It will take it on your own. Okay. So it will be grateful if you define SNS. If you like, it will be grateful if you know both those things, SNS and Matplotlib. But coming to some other plots, Matplotlib is very useful than SNS. So I recommend you all to learn both the plots, how they work and when to use what kind of plots. So after this cell, we'll be importing the data. Okay. So after that, we'll be knowing what is the shape of the data frame. So this function will tell us what is the rows and columns we'll be having. If you can see, we are having 1338 rows. Okay. We'll be having 1338 rows and 8 columns. So if you look at this, we can have 1, 2, 3, 4, 5, 6, 7, 8. 8 columns, and the last cell that we are having is 1337, and the cell we are starting from is 0. So 1337 plus 0, whenever you're starting count as a human, you will be starting the count from 1, not from 0. So whenever you're doing this, you'll be having 13, 8, 38 rows and 8 columns. That is what the df dot shape defines. And coming to this df dot is null sum. Okay, so we already know what is the df dot is null. So whenever you remove this is sum, let me just run the cells again. Okay, whenever you give this function df dot is null. Okay, now df dot is null is nothing but the checking whether the data frame has some like null values or not. So the first 5 rows and the last 5 rows doesn't have any null value. Okay, so whenever you're getting any null value, it will state it as true. Whenever not getting null value, it will state it as false. No, if you look at this example, it states that there is no null value. But when using this sum function, okay, whenever you're using this sum function will tell you how many null values are there in at any column. So if you look at this, yes, let me just restart the session so that we will be having a better understanding. Let's check by running this thing if you're getting any. Yeah. So if you look at this, now you might get the doubt why I am running this thing. So to understand that whether the runtime has been deleted or not. So when the runtime is deleted, the package which I've installed, it's not installed in this Colab notebook. So the thing which I try to run right now is pd.readcsv. So if you look at this pd.readcsv, pd is from pandas library. Okay, when I report this libraries only, this thing works. Okay, now I imported. Now whenever I try to run this again, now this works. Okay, now we'll be learning about the shape again. We'll be learning about is null sum. Okay, now when you check, we'll be having 8 classification errors. Okay, now we are having 8 classification errors. So we need to analyze what are the 8 classification errors and everything. We need to look at this thing. Okay, now this is what the classification shape and everything. So the classification errors that we'll be having is the missing value percentage is around 0.597, like something or some other random number. Okay, now you need to understand that around half values are missing values right now in the classification. The missing percentage is nothing but the null values what we'll be having. If you look at this, out of the thing, okay, now what we are trying to tell you right now is the missing value percentage in this class of column is out of the entire columns and everything that we're having. Suppose if you look at this, what is the shape that we're having? So from that, it will calculate the missing value percentage. So if you look at this, out of the entire data that we're having, out of that, around 0.59% is having missing values. You understood this thing? Yeah, that means more than, yeah, that's what we're saying. Correct. So we see that classif has 8 null values. It records are missing information. Okay. So what are the information that you're seeing? Class if column has 8 null values. Now we can understand looking at the statement also. Class if column has 8 null values. So the class if column has 8 null values. What we'll be doing is, so we need to check the missing value percentage after that. So why we need to check missing value percentage? Because 8 missing values in a data set of 10 records. Okay. Now we'll be having 10 records. After that, we'll be having 8 missing values. So it's a big deal. But 8 missing values in a data set of 1000 records. So why we need to check the percentage? Because whatever the records we'll be having, whatever the rows we are having. So out of 8, if you're having 8 missing values, then it will be tough for us to consider the column. Okay. Out of 1000 rows, if you're having only 8 missing columns, then or 8 missing values, then it will be okay. Because 1000 is a big number and 8 is a small number. You can directly eliminate this 8 and you can have the 992 for your classification or regression. So that's the reason we'll be performing this trick so that we'll understand what is the this calculation helps us to understand the impact of those missing values that we'll be having. So what is the data set and the missing values connection we'll be having, you can understand where you can get this thing. So if you look at this, here we are dividing with the entire rows that we're having and also what are the missing values we'll be having. So for that, we'll be dividing between the entire rows and we'll be checking the percentage. After that, we'll be using this fill now. Okay. So this replace the missing values. Okay. If you look at this, replace the missing value column with using mode. We'll be using this mode. Okay. Now instead of mode, you can use mean also. So we have chose when dealing with missing values, we can remove the rows and columns. Okay. So not the columns, we'll be removing the rows with missing values or we can fill them. So since class is a categorical column, what we'll be having. Okay. And this fill with mode in a common strategy. Whenever you're using this categorical values, we'll be using mode to fill the missing values in categories. Okay. So if you look at this df of class if mode of 0. Okay, now this finds the most frequent category in the class column. So what is the category that is being repeated mostly? That we'll be using to fill this 8 missing values. Okay, now fill now is nothing but what is the function that is being filling the missing values. Okay, fill now is a function that is being missing the values. Whenever you see in place is equal to true, means we are making the changes directly to our data frame rather than creating a copy. Whenever you are removing this thing, this will create a copy. Okay, now you are removing this in place is equal to true. What are the changes that you are making in this function? It will be saved as a copy in your image. So when you're editing an image, you'll be having two options: save a copy or save directly. So whenever you click on save directly, the original image will be changed. So whenever you click on save a copy, a new image copy will be saved. So this is the reason why we'll be using in place is equal to true. Okay. Now after that, if you look at the categorical values, these categorical values are filled with more of these categorical values that are being repeated mostly. Okay, now we'll be checking again. So df dot is null sum. Now again, this confirms the missing values that are gone now. Okay, so it's to double check before going to the next function. So next thing we'll be seeing is df dot duplicate dot sum. Okay, this helps us to find if you have any exact copies of rows in our data set. So first, whatever the duplicate can skew our analysis, so it's better to handle them. What other duplicate values will be having, we will be getting to know whenever you run this thing. So if you look at this, you can also remove the sum here and run this thing. Whenever you run this thing, it will give us false, true, everything will be Boolean. Whenever you remove the removed thing, that means whenever you give the sum again, it will tell you the numerical format of telling whether we're having any duplicates or not. So if you find any duplicates, we will usually remove them by using drop duplicates. Okay. So drop duplicates the function that will be used to remove the duplicates. If you do this function to directly remove the duplicates, that means it will delete the duplicates from whatever the data set we'll be having. So keep first. That means whatever the duplicate that is being repeated, the first value will be kept and the remaining values. That means suppose if you're having 5 values, out of these 5 values, the first value will be kept and remaining 4 values will be duplicated, will be deleted. So what are the first value that we're having? The remaining four is a duplicates value. Okay, no, only the first value is being kept. Remaining four values will be deleted. This is what keep first means, and also in place equal to true means we are directly changing the original file, not creating any data frame exact copy. Okay. Shubham, I didn't get you when you mentioned the comment in the chat. So can you please give your question again so that I can understand more properly? So when you mentioned is it, I didn't understand what this is it reference to. Now we are currently performing this exploratory data analysis. Okay. Now whenever you're performing exploratory data analysis, we'll be checking whether data is being managed equally or not. Okay. If we are not managing the data, so then we'll be getting some errors like overfitting and underfitting, right? So what are the high variance and bias we'll be having that we can see if we don't perform our activities properly. Shubham, I hope you understood this thing. Please give some response. Shubham, the query which you asked regarding the data leakage, of course, we'll be getting the data leakage if we don't do this properly. What are the things we'll be having? They were asking if you the missing some mode of folder. Yeah. So whatever you're trying to tell that is being correct because fill all the missing values using this mode, the data leakage will occur, but only if you do this incorrectly. So in the CDI phase, we are just exploring data, not training the model yet. Okay. So we are just telling you, explaining you how we can do these things and everything. So it's okay to fill the missing values with the mode of the entire data set just to get a feel for the distribution. Okay. So whatever we are using, we should not use this while we are training the model. So while we are, as we are discussing that in ADA, we are doing this thing, right? While we are doing this model building phase, if we fill all the missing values using model, like what you asked is more calculated from the entire data set, you are allowing the information from the future to leak into your data set. Okay, what are the things you're having? You are allowing the machine to fill the data before you are giving the thing. So it gives the model an unfair advantage and it causes the unrealistic problem what you'll be having. So it will always have upper hand on the whatever the data that we'll be having. So before only the data which we are having most occurrence will be replacing, right? So yes, we'll be using this Filna to fill the values, missing values, what are the missing values that we'll be having? We'll be using the fill not fill the missing values. So while filling the missing values with mode, you will be usually interested in just one value, right? What are the values you'll be filling? You'll be only wanted to fill one value. So whenever you use this mode function, you can return multiple values because mode will be having multiple values. So whenever you return this mode function, you'll be having multiple values. So what you'll be doing is whenever you keep this thing, suppose if you're keeping this thing, close brackets of 0, this will select only the first one to keep the like missing value simple. What are the missing values, like what are the most occurring elements that we'll be having? From that, we'll be selecting the first element and we'll be replacing that with the other missing values. So it's completed. Now we'll be doing this drop duplicates. This is a function for dropping the duplicates. So if you look at this, keep first, we'll be keeping the first thing and in place true. So when you click on this in place true, it will only modify the existing, it will not create a new one. Okay, I hope everyone knows this df.info. df.info will define all the info about the dataset that you're using right now. Okay, now this describe function, whatever having, will describe the dataset in a much more understandable format. So if you look at this, so this is the count, mean, standard deviation, median, like minimum value. Okay, this 25, 50, 75%. I will explain. So if you look at this thing, okay, so this is the info of this. Suppose what are the data types you're having? Is it having a null value? Okay, and what is the things that you'll be having? So this is what you'll be seeing in this thing. But coming to describe, so here it describes the data. So in age, you're having this is the count of ages what you're having. Okay, now 1337 is the entire row. Excuse me. So in the 1337, it's the entire row. That's why you're seeing 1337. So coming to this mean, this is a mean age. That is the average age. This is the average age that you'll be having in the entire data set. Okay, we're having an average age of 40. Coming to the standard deviation, we're performing some standard deviation operations on every column and giving the math here. So this minimum values that we're having is minus 58. Okay, so this is an incorrect data type. Okay, whenever you're seeing the age in minus 58, that is not the thing that you'll be seeing. So this 25, this minimum and median, like minimum and maximum will stand for the smallest and the largest values that we'll be having. So coming to this 25, 50, and 75%. So this is the called as quartiles. This is called as quartiles. Okay, no, this is also called as median, mean, and some other thing. So why we'll be having this Q1, Q2, and Q3? Because so this Q1, Q2, Q3 will categorize the data into three parts. Okay, so this data what you're having, so this age will fall under this category where 50% of the data, whenever you're having a range of data, so at 50% point, this is the age. Okay, now if you place the data, what are you having? So what are the 1337 rows you're having? if you place them in ascending to descending order or some order wise or whatever you're having. So the quarter cell, what are the medians and where you'll be having. So 50% is the median. The 50% is the middle value that we'll be having. And after 50%, 0 to 50%, what is the middle value that we'll be having? That is 25%. And from 50% to 100%, what is the middle value that we'll be having? That is 75%. I hope you understood this thing. So Shivam, that is what I'm telling. If there are more than one value with same frequency in the case, we can have multiple modes. So we are selecting the zeroth elements, okay, based upon the sort, the first one that we are using. So computer understands the numerical format from zero, right? So whenever the elements are like assigned in a format, so what we'll be doing is, so whenever we are doing this, the first element that is being most repeated, suppose we're having a numbers like 1, 2, 2, 3, 4, 5, 6, 6. Okay, now imagine what are the things you're having. 2 is repeated 2 times, 6 is repeated 2 times. Okay, now what is the first number that we'll be seeing? That is 2. Now this missing values, whatever we're having, this will be filled with 2 value. Okay, and there is a negative value in each column, that is because of the incorrect value of the data. You guys have understood this thing. Now for describing, we are importing this tabule. Okay, this is for giving the data into a tabular format. This code will define the what are the values that we're having into two things, that is categorical and continuous. So categorical represents the text, that is objects and everything. Continuous represents the numerical. So whenever you're using this tablet library, okay, this tablet library, use it to print the list nicely, make it to see the columns which you're having. So what are the things which you're having? It will be also helpful to understand data types in Crucial. And also this will be useful for treating numerical data and categorical data in a different approach. Whenever you're seeing this thing, it will be automatically categorizing this thing so that we can understand what is numerical and what is categorical. Okay. So here we'll be going into most, like here we'll be getting more into this categorical features. Okay. So here the cat function, what we're having, the first thing, this cat function designed to give us the key facts. Okay. Now it is designed to give us the key facts what you're having. So this will print us unique values, missing values, and mode of. So why we didn't get any output? Because we didn't call the function. We defined a function, but we didn't call the function. I just only created a function. So whenever I'm using, so this main category can be represented with any of the gender. Okay, so we're having multiple things like gender, class, if smoker, region. So I can replace this gender with something like smoker. Okay, now if you see this main cat, there is a function that we're having, it is calling this thing cat info. Okay, no main cat of call. So in this main cat of call, you'll be having cat info of column. Okay, whenever this cat info of column is being called, it is being going the function to here. Whenever the cat info of this is being called, we are printing unique values, missing values, and mode of. Okay. If you look at the print statement, this n unique, whatever you're having, this n unique is function that will describe you how many distinct categories that you're having. Okay, suppose we're having male and female. So these are two unique values. Okay, these are two unique values. And I hope you all know this is null dot sum. This is a function used for getting the sum of the null values that you're having. And also this mode of 0 will give us the most frequency. And why we are using this most frequency 0? Because we have discussed just now, whenever you're having multiple numbers with same frequency, we'll take the number that is from the first index. Okay, from the index wise, when you're going, the first index number that you're seeing, you'll be taking that as a mode. Now, function value underscore counts will tell us what is how many times each category has approached and how many times each category has been counted. And these are this normalize is equal to true. Whenever you see this thing, normalize is equal to true. This percentage breakdown of the each category, what we'll be seeing. So, what are the breakdown that we'll be having for every percentage, we'll be seeing this thing. Okay, whenever you mention why do we gain, what do we gain from this, we'll be having an understanding of every column what you'll be having. Okay, now if you represent this previous column, the gender, if you look at this analysis, in gender we'll be having two unique values. Okay, missing count will be having 0. We'll be having 0 missing count and mode of gender. That means male. So when you look at this mode of gender, this represents that this male categorical value that is being represented multiple times. Okay, more than the female value. So whenever you're having a categorical values, which category has been represented more times, that you can see this category. And also look at this graph and also this percentage. So 50.5 percentage and 49.5 percentage. We'll be having a plot and everything. So for this, you'll be having TF underscore visual. For this, you'll be using Matplotlib and SNS. So in the same way, we'll be looking at this main main cat is a function and this classif. So why we are taking this classif? Because remember these are the four categories that we'll be having. So we'll be having the analysis of four categories. So what are the four categories? Gender, classif, smoker, and region. So the first thing, gender is completed. Now we are doing this for classif. If you look at the classif function, the unique values we are having in classif is 6. Okay, the missing code will be having 0. Mode of classif is 0b1. Sorry, it's OB1. Now, if you look at this thing, OB1, Prio, and OB2, OB3, UV. So, if you look at these values, you can understand what is the majority value and what is the least update, like least occurred value, and you can understand the percentages by looking at the pie chart. Now, by looking at the pie chart, you can understand what is the values you'll be having and everything. Now we'll be going on to the next category, that is smoker. Okay, now just now we have seen the smoker, how it works and everything. Now we'll just run this thing. So unique values for smoker, yes, or we'll be having only two, whether he's a smoking person or whether he's a teetotaler. Okay, now we'll be having two categories, that is whether he's a smoker or whether he is not smoker. So coming to two categories that we'll be having, so missing count 0, mode of smoker no. So if you look at the categories, around 1,000 plus persons are non-smoking category, coming under non-smoking category, and only a few comes under smoking category. So this is a bar plot. This is a pie chart plot. I hope everyone understands these plot names. So last thing we'll be having is for region. And also, you can have a small analysis. Only 20% of the people smoke. Most of the people are in obesity stage 1, followed by pre-obesity stage and underweight category around 1.4%. Okay. Now, by looking at this thing, you can make some assumptions, make some understandable analysis and everything. Now, what will be having? We'll be having 4 regions. We're having 4 regions. So from southeast, the region is this count is slightly more when compared with other regions. So this tells us the geographical distribution of our data, how we are distributing and everything. So how we are distributing and everything. So coming to this thing, so what are the 4 values that we're having? Southeast, southwest, northwest, and northeast. So what are the distributions that we see? We can see that in the pie chart. So 24.3%, 27.2%. Okay, with the minimal of 3-4 percentages, the everything has been changed. So you can look at this southwest, northwest, and northeast are having almost equal data. And coming to this southeast, it is higher than other 3 regions. Okay. Coming to the next function that we'll be doing. So we'll be going with numerical features. Until now, I have discussed about categorical features, right? Now we'll be performing the column analysis for numerical features. So what are the things which are done? We'll be doing the same. So mean, skewness, and KUT. So before going to this thing, I'll be explaining what is mean, skewness, and KUT. So what are the functions that we'll be having? Mean function, skew function, and KUT function. So I hope you all know this mean function. It is the average value what we'll be discussing. So what is the skewness? Skewness is nothing but, so whenever if you're having a pizza, whenever you're dividing a pizza into multiple pieces, so which one piece is having bigger thing, that is called as skewness. Okay. So this skewness is nothing but tells a symmetrical value. Okay, what are the symmetrical value that we're having? If a pizza is there, we can directly cut the pizza into 6 equal shapes. But whenever you're having non-symmetrical data, that we can measure with the help of skewness. So if it is leaning, if it is completely coming to one side or not. Okay, so example, if a skew means a longer, okay, let's take example. If the skew means, this Q will help us to understand how much it is distributed from normal distribution. So what are the things that we're having? How much it is distributed from normal? Okay, let's take this example. Suppose, yeah, this is what skewness is. Okay, if you look at this thing, this is 50, this is 50. You cannot 50. So what are the things that has been gone to right and what is the thing that is gone to left? Okay, it is telling us what is the distribution that is for entire thing. Come to the KUT function, it measures the tailness of the distribution. Okay, suppose this will measure mostly the outliers. What are the extreme outliers or the outliers that we'll be having, we'll be measuring using KUT function. Okay, now if this is computed, we'll be going with this category numerical values that we're having. So the main of this what you're doing is age. So first we'll be having with age. So you're right, if the age column has negative values, that is clearly invalid data. Okay, now what we'll be doing is we should fix the thing directly. Okay, we'll directly remove the thing that is df dot drop now or some other things, or replace like fill now what you'll be using. So this will fill the age with medium mode. Let me see where the age value is there right now, where you're seeing. Yeah, Shivam, that code which are given in the like the logic that are given in the chat works because whenever the age is less than zero, we can directly drop. Or what are the things that will be think that doesn't come under negative? Suppose what are the money or some other categories that we think that comes under that doesn't come under this my negative or positive category. So we can directly drop them. So as you did, we can directly drop this age by where age is less than zero. Okay, now we can do this, but this time, what are the things that I'm explaining for now? It needs to have some errors so that you'll be understanding more when you're having some errors to understand. And also, it will not be sufficient time to explain you first time and going back and like solving the errors and everything. So as we only have this 1 hour left, we'll try to complete what are the topic we are having right now. As you told, so this is what you told right now, right? So we can directly df.age. Okay, now what we'll be doing is we'll be removing this thing. And that is what was defined in this thing. So if you look at this plot exactly, so this is what mean, skewness, and kudos will help you understand. So coming to the next thing. So as you can see that we'll have a negative values. So what I'll be doing is I'll be removing the negative values. So as age is having some outliers, so we'll be removing the outliers with mean value. So what the df dot frame is having, so we'll have the age will it will be greater than 5 or it will be sorry the age will be if it is less than 5 or if it is greater than 100, we are taking the age into 0. Now we are taking the age into the mean value what you're having. So if you look at this main age again, so what are the functions that we'll be doing? This will replace the value. Yeah, we are not just dropping, we are replacing it with the mean value that we're having. So we are mean value, what are the things we'll be doing? We are replacing the thing. And also I can see the difference that we're having right now. Sorry, I didn't think I run this thing first. Need to run this cell. Now we are seeing the difference. Okay. Now we can see the difference that mean, skewness, and kudos has been changed. Yeah. So most customers that we're having is in the age of, so you can see most customers that we're having is 20 age. Okay, so after 20, the most customers will be having is from age 30, and yeah, age 30 is the next thing. So this might be the approach. So after that, we'll be calculating the BMI, taking the data frame into consideration. We'll be calculating the function with BMI. So the same thing you'll be seeing mean, skewness, and kudos also you'll be seeing for the BMI, body mass index, and everything. So children, what are the children, what age they come from and everything, we'll be seeing this. So not the age, what is the count we'll be having. So this is the other way, like other multiple variations of this numerical categories. Coming to the charges, how much they charge for the insurance. So if you can see, we'll be having a value from this to this. Okay. So these are the values that you're having right now. The things that is far from each other. Okay. Whenever you look at the data, these are called as outliers. Okay. So called as outliers. So we need to remove these outliers. So remember this thing, guys. Whenever you're seeing this diagram, we need to understand how many outliers that we're having. So in the thing, in the upper case also, we didn't have any outliers. But coming to this charge, what are the incidence charges that we're having? You can see that outliers that is being mentioned here. So here we are identifying that charges, right? So it's the thing which will be predicting, right? Charges. Okay. Now coming to the thing, we'll be using some criteria for outlier handling is clipping or some other thing. With clipping as a technique that we'll be using. So clipping is a technique we'll be using for removing this outliers. So what this clipping will do is instead of replacing the outliers with mean values, okay. So generally we'll replace the outliers with mean values, but instead of doing this, what it will do is it will set the value about the certain percentile. What are the certain percentile we'll be having? We'll set the values between certain percentile and that to the percentage value that you're having as an outlier. So instead of having this mean value, we'll set the values about a certain percentile to that percentile values that you're having. Okay, so if you look at this thing, we can understand that majority of the charges that we're having is in the range of 4,000 to 17,000. So that is for this thing, 4,000 to 7,000. You can understand by looking at this thing. So in the next cells, we'll be understanding about the bivariate and multivariate analysis. Okay, so these are the these are the graphs and everything that we'll be doing with the help of Matplotlib and Seaborn. Okay, remember the technique that we'll be using for removing the outliers. We'll be using clicking. Clipping is a technique that we'll be using for removing the outliers. Okay, remember the thing, guys. So now let's go to what bivariate and multivariate that we'll be having. Now going back to this bivariate analysis. So in this bivariate analysis, we'll be doing for the categorical values based upon charges. We'll be using clipping technique. Okay, we'll be using clipping technique. In this clipping technique, what we'll be doing is, okay, instead of replacing the entire outliers with mean values, we'll be setting values above certain percentile. Okay, we'll be having a percentile or we'll be having a certain criteria. Above this criteria only, we'll be replacing the values. That is what clipping process is like. Clipping process is all about. Excuse me for a second. Yeah, we can also use IQR. What is the method you have mentioned? This IQR method is most commonly used. So this will remove the extremely values based upon the interquartile range. What are the interquartile range? That is Q1, Q2, Q3 that we'll be having. Based upon the thing, we'll be removing this thing. So what are the thing that I have told you? What is clipping that all be using this? So this clipping, so not clipping, this is capping. So this capping will be used to replace the outliers with threshold values. What are the threshold values? Something as I have taken, suppose I have taken certain criteria. Okay, above this criteria only, I'll be having some values. So below this criteria will fall on the outliers. Now what I'll be doing is I'll be placing my outliers values above this criteria. That is what this clipping is all about. Coming to this IQR method, what you have mentioned right now, this IQR is a percentage. This IQR is a technique that is used for removing the outliers what you're having. So how we'll be removing? We'll be removing based upon Q1, Q2, Q3. What else that I have explained right now? 25%, 50%, and 75%. Okay. So we're not removing these things, we're instead adding or replacing these things with clipping, not the clipping, sorry, clapping. Sorry, not clipping and clapping, it's capping, CAPPING. Okay. It's capping. So it's a pronunciation mistake that I'll be doing frequently. I hope your doubts has been solved. What are the techniques that you mentioned? It comes under regularization. Okay. Lasso and Rich are regularization techniques. So regularization the topic. Okay, in this topic, regularization, Lasso and Rich are the techniques. Okay. So this Rich, what you mentioned, is called as L2 and Lasso is called as L1. So we'll be commonly mentioning these names as L1 and L2. I hope you must have heard these names L1 and L2 regression, but these names what I'm telling right now, Lasso and Rich, are called as L1 and L2 regression techniques. Yeah, we'll be handling those female and male separately. Okay. What are the distributions that we'll be having? That's entirely different. We are not doing mean, median, and everything. So what we're doing is we'll be checking the age distributions of gender, what we're having. Okay, after checking, we'll be understanding what are the differences that we'll be having. So after getting the age data and after understanding the differences for gender and the age, so then we'll be performing this outlier techniques. So if you look at these plots, these are the plots that we'll be using for bivariate and multivariate analysis. Sorry, bivariate and multivariate analysis. So I hope you all know understand. You all know what is this bivariate and multivariate is. Bivariate will help you to understand what is a understanding. So what not to understand what is the connection between multiple columns. Okay, what are the multiple categories or features that we're having? So what is the connection? What is the connecting component that we're having between these multiple components? We'll be understanding by using bivariate analysis. If you look at this figure, okay, so female and male based upon the charges. Now you can understand what is the male charges and what is the female charges by looking at the plots we'll be having right now. Okay, So here we're looking at this Seaborn dot box PLT. Okay, so this is a block spot. So if you look at this SNS, this will understand that you can understand that this is a Seaborn taken plot. Okay, this is very useful for understanding what is the categories we'll be having and also the insurance that will be distributed. So for example, if you see this smoker, we are having this smoker plot, right? So if you see this smoker plot, we'll see one block plot for yes and another for no. Okay, no. When you're seeing this yes, allows us to understand what is the visual comparison that we'll be having between yes and no. What are the median charges that we'll be having? So if you see the median charges that we'll be having for no is around 10,000, around 10,000 to 20,000. Okay, at max we'll be having around 10,000 to 20,000. But coming to the yes, it's around 40,000. So however, smoker will get affected very fastly. So based upon that thing, we'll be categorizing this thing. I hope you understood how this bivariate and multivariate analysis. I didn't run this. Okay, let's run this thing. Issue. So this is what the bivariate analysis that we're having. So based upon the charges. Here we're having scatter plot. Until now I've seen this box plot. Now we'll be seeing about scatter plot. So this scatter plot is added with regression line. What are the regression lines we'll be having? So we'll be using this scatter plot, and this line attempts to show the linear best fit with two variables that we're having. Okay. So if you look at this scatter plot, so this shaded area, what are the area that you're having around the line representing this? Okay, this will tell the line slope upwards and suggest the positive relationship that we're having right now. And also, if you're looking at this graph, BMFS charges. Okay, if you're looking at this charge, BMFS charges, here you'll be understanding that higher PMI will be there whenever you're having higher charges. Okay, the body mass index will be higher when you're having higher charges. That is what we'll be understanding from this scatter chart. So most number of people that we're having are from this category. Okay, so you can perform some clustering by looking at this thing. So let me just go with the blocks plot. So here we are using this box plot. Okay, this Seaborn box plot. Okay, so this SNS dot box plot, whatever we're having, this will help you to understand how categorical values, how categorical features, like categorical features that we'll be having is gender, classif, region, and smoker. These are the four categorical values. This how they will affect the charges, how they will affect the numerical value. Okay, one is categorical and one is numerical. At that time, we can use this box plot. This each box plot shows the distribution of charges for each category. What are the categories that you're having for each thing? We'll be having a numerical distribution. For example, if we are taking this obesity and everything, okay. So even also if you take the region, from all this region, we'll be having most number of charges. I don't know the reason why we're having. Okay, so if you can think that most of the obesity that we're having is from southeast region. Okay, is from southeast region. So that is the reason we're having more charges from this region, and we're having less charges from southwest and northwest. Okay, the first two regions that are paying more for the charges is southeast and northeast. So the thing we'll be seeing here. So this will help you to understand the comparison of categorical numerical values. What are the categorical numerical values that you're having? So this will help you to understand how they are connected within each other and how they will make you to understand the data more understandable and more with more clarity. So I hope you understood this SNS plot also, scattered plot. Now, if you look at this, this is also a scattered plot, but for BMI and charges. What are the BMI that we're having for that and charges? Okay, now the region that we're having. Okay, so this is entire charges that you're having, and also this is the body mass index. Okay, suppose you're having body mass index around 35, most of the charges that we'll be having is below 30,000. Okay, below 40,000, below 30,000, you will be having most of charges. Okay, if your body mass index is around 20, then no charge that you're having is greater than 40,000. Okay, you can take this kind of analysis and also. But if you look at this, the shaded region that you're having, okay, this shaded region, set the line, you'll be having shaded region, right? So, okay, the what is this line is? So this is a regression line. What you're having, this regression line is mostly trying to become the best linear fit for the two variables that you're having. Okay, it's trying to beat this line. What you're having is trying to get the best fit for the data what you're having, and also from this best fit we can perform the model analysis. Okay, so after this shaded line, what we're having, this shaded area that is around the line that represent the confidence interval. Okay, if the line, if we are having above the line, it is positive. If we are having below the line, that is negative. That is what this chart indicates. Now we'll be seeing about multivariate analysis. This multivariate analysis will help us looking at the relationship between three or more variables simultaneously. What are the variables that we're having? We want to look at three or more variables simultaneously. Then we'll be using multivariate analysis. Okay, so we'll be creating multiple conditions to understand these things. So here the categories that we're having is gender, male and female, and also this smoker, yes and no. So the first plot what you're seeing right now, showing the classification about the so the first plot what you're seeing right now is showing the classification about the obesity and everything. Okay. So what are the obesity and everything that we're having? It will help you to understand this thing. So within this group, the obesity groups that you're having is broken out into regions, multiple regions. For multiple regions, we'll be able to understand what is the count we're having for this obesity criteria. Okay. So now if you look at this thing for OB1, obesity 1, we'll be having most number of obesity 1 patients from Northwest. Okay. And the least from Northeast. Okay. So coming to the least obesity patients from OB1, you will be seeing that from, sorry, you'll be seeing the least number of patients of obesity 1 is from Northeast. Coming to entire region, okay, so coming to the entire region, we are having least number of OB3 in Northwest. Okay, we are having the least number of OB3 in Northwest. But coming to this OB1, we are having most number. Okay, these are the small understandings that you'll be having when you're performing this multivariate analysis. And you can understand what is the relation between multiple categories and multiple columns. So the second part what we're having is between BMI and smoker. Okay, if you're having smoking habit, and also what is the BMI you're having. So for this group, will smoker will be only yes. Due to our filter, it's good to see the BMI distribution for the specific group that we'll be having. So this multivariate analysis are about segmenting our data and also understanding the specific patterns that could be important for our model what we're having. So the next thing is we'll be implementing a linear regression model. Meanwhile, I'll just ask you guys. So do you want any break for 5 or 10 minutes? Give me some response that do you want any break for 5 minutes? So you can take a break for 5 minutes and you can come back by 7:40. Okay, we'll have a session until 8. So make sure you come early. Welcome back, class. I hope everyone is present right now. So if everyone presents, we'll start the class directly, or we need to wait some minute, or shall we start the class right now? I need some confirmation regarding that. Guys, give me some reaction as soon as possible because we are only left with 15 to 10 to 15 minutes. So if I get any reaction as soon as possible, we'll start the session. Yeah, thank you, Anjali. So we'll be going on with label encoding. Okay, in the linear regression, what we'll be discussing right now is label encoding. So coming to this topic, so what are the machines like? What are the machine learning models that you're having? These machine learning models are mostly of mathematical part. So what are the categorical that we present? Suppose age, gender, classic. What are the things that you're discussing, defining? So we don't. The machine don't understand these things. Okay, so they're not understand by the machines, but we can understand this. So what we'll be doing is, so for processing purpose, we will be converting them into numerical categories. Okay, so we'll be having this pre-processing dot label encoder. So this is what the thing it is. So this pre-processing dot label encoder is it is a tool that will be converting the text categories into unique numbers. So for example, let's take this gender thing. Okay, so for gender we'll be having two genders, that is male and female. So what we'll be doing, we'll be getting male 0 or giving male 1. We'll be having 0 and 1. We'll be getting we'll be giving male 0, female 1, or we'll be giving male 1, female 0. Okay. Either way, we'll be defining a unique number for the genders so that they will be understood by the machine. Okay. So that is the thing we'll be doing in label encoding. We are performing a for loop. Okay, for every I iteration that we'll be having in the data frame, we'll be transforming that into label encoder. What are the classifiers that we'll be having? We are transforming that into label encoders. So after that, you can understand that everything is of integer and float category. Okay. So no is of nothing is of text or object. So everything is of data type. Every data type that we're having right now is of float and integer. No data type is in the category of character like object or text. Okay, the next thing that we'll be doing is feature scaling. If you look at the down, this is what we're performing. Okay. Now this feature scaling, what this feature scaling is like. So understand just by looking at this comment what we're having in the above thing. So feature scaling all numerical values under one scaling using min-max scaler. So this is what the feature scaling generally is. So by giving an example, imagine one feature that is there, that is age. So this age is around 18 to 16. Okay. So this age is of 18 to 16 and another charges that is from 1000 to 60,000. What are the things that you're having? Age is from 18 to 60 and this charges is from 10,000 to 6,000 to 60,000. If we give this raw numbers to the model, so charges is of larger magnitude and age is of smaller magnitude. So 18 to 60 will be classifying under below 1000. Okay. So even if you take this 1000 category, 18 to 60 is far less than 1000. But coming to 60,000, 60,000 is very far than 18 to 60 category that you're having. So what we'll be doing is we'll be taking a similar range so that every number what you're having will fit in the range. So if you look at the age will be coming into 0.02. In the same place, charges will be in the 0.25. So what are the range we are having for multiple categories? Multiple categories like this is numerical categories. We need the range to be in single range. Okay. We need the age range to be in a single range. Okay. So what is the range that we'll be taking? We're taking a random range of 0 to 1. So what are the range that we're having? Every numerical range that you're having is in the range of 0 to 1. Okay. So no number that is less than 0 and no number is greater than 1. I hope you can see this thing. So if you look at this function, what are the scalar that we'll be using? We are using min-max scalar. So this min-max scalar is a scalar that scales all the numerical features into a specific range. So what are the specific range that you're defining? 0 to 1. Okay. You usually take it mostly in the range of 0 to 1. So this ensures all the features that you're using contributes equally to the model learning. So this will prevent having features that are larger and also having features that are shorter. So by this, we'll be having some range influence on another factors. So to remove this thing, range influence on other factors, we'll be using this min-max scalar of 0 to 1 to have every range that we're having in a single category, okay, in a single range. Now we are having this correlation. This correlation is a table, okay. So if you look at this, it's showing a table. So this table kind of structure. So this table shows how strongly each pair of variable in the data set is related, okay. So if you see this thing, age and age is a single thing. No, they both relate to one like at one point. But coming to age and gender, they relate to minus 0.02. So this minus represents that will be having some negative effect. Okay. That means if yes. So what are the fit function that we're having? So as per the doubt that you asked, that is the difference between fit and fit transform. So this fit learns the parameters like mean, standard deviation, min, max, and it doesn't change the data accordingly. So whatever you're doing, scalar dot fit data. So it is actually understanding the parameters and it directly fitting the data. So whenever you're trying to fit underscore transform, so it learns the parameters and it's applying the transform step. Okay. So in this fit underscore transform, it is doing two steps. One is fitting the data and also it is transforming the data. So if you look at this transformation, what it's doing is transforming into the categories what you're transforming that into the function what we're applying. Okay. So if you look at this fit that we'll be using it mostly in model.fit. If you look at this function model.fit, what we'll be doing is this model what we're having is trying to learn the patterns. Okay, this model.fit, whenever using this fit function, this model.fit will try to understand the patterns of the data. But coming to fit underscore transform, this fit underscore transform is doing two operations here. It is understanding the patterns and also it is transforming the data. Okay. I hope you understood this thing. Coming to this correlation matrix, whenever you're seeing this negative, this represents will be having some negative effect. Okay. So age and gender will be having a negative effect on each other. So coming to the positive effect, that is age and BMI. So if you look at that, age and BMI will have some positive effect on each other. This is what the correlation matrix represents. This is representing the entire features one to each other, how much they have some equation and how much representation they'll be having, and also what is the connecting equation, like not the connecting equation, what is the term we'll call right now. So how much impact they have on each other. Okay, the term will, I'm thinking like the impact. So if you look at this age, gender, and everything, how much impact each feature holds on another feature. That is what we'll be discussing in this correlation matrix. And coming to heat map. Heat map is a visualization of correlation matrix that you're having. So what are the matrix that is having? This is just a representation. And based upon the intensity, you can understand. Okay. The positive the color is, the darker the color, like the positive the value is, the darker the color will get. Excuse me. So this is what soil correlation is. So we're just taking a threshold value for this correlation, and we'll be seeing that. Okay. So if you look at this thing, this means that what are the plots that we'll be having? Okay. So what are the, not the plots, what are the correlation matrices that we'll be having? So this function that exists, like this should not exceed 0.5. So whenever it is exceeding 0.5, it will be having darker color. Okay. So coming to the next thing, so we'll be having, so this pair plot. Okay, we'll be using a pair plot. So this pair plot is similar to the one that we saw earlier. Now we are using this to have an argument between hue and smoker. So this hue is what smoker is. So this means that in each scatter plot that we're having, the data point will be colored differently. So based upon the whether the person is smoker or not. So we are taking the smoker because it's a category. So if it's a 1 and 0, we are having two conditions. Okay. So based upon his smoker, that is yes, that will be having it as 1. If it's no smoker, it will be having it as 0. Okay, based upon two categories, we'll be defining the data into two things, and this can reveal interesting patterns what we're having based upon every category that we're having. So you can see class F, children, religion, charges, BMI, gender, and age. So based upon everything. So if you remove the smoker and give something like, let's take gender. So meanwhile, let's okay, has given you specifically. So I can see with respect to gender, you can see gender is having only two categories. It's like one is male and one is female. So based upon gender, smoker, region, charges, children, classic and BMI age. So based upon what are the thing you're giving. Okay, so this pair plot is nothing but comparing every other category with a single category. Okay, whether it is numerical category or categorical category. So for everything what we're having, we'll be performing a categorical visualization. Okay. So now we are just doing the splitting data. So I hope you understand how splitting data works. So this is a critical step what we're performing in machine learning. So we divide our data set into two main parts. One is X and one is Y. So X is independent, Y is dependent. Okay, we'll be having this Y is equal to MX plus C. I also told you with this equation. Now I want you to remember this thing. X is independent and Y is dependent. So X is our input features, what we're having, and Y is our target variables, what we need to predict. So what we need to predict here, based upon the above thing that you're seeing, we need to predict charges. Okay, based upon the above cell that you're seeing, we need to predict charges. So we need to have this splitting of data of Y. So this Y is equal to df of charges, X is equal to scale underscore data, like scale underscore data frame, drop charges axis 1. So now what we are doing is we create an X by taking all the columns from scale underscore df. Okay, we are taking a data frame. From the data frame, we are except charges. Charges is at axis 1. Okay, that means we're dropping a column. We're dropping this charges column and we're taking the entire data frame. Okay, now if you look at this, usually we used to have 8 columns, right? Now it is 7. Even if you count 1, 2, 3, 4, 5, 6, 7, and 1 is mentioned in this thing, that is 8. Okay, now what we'll be doing? We'll be training with one lesser column. Okay, now you're predicting values with 1337. Okay, now that is what you'll be seeing in the Y shape. Here we are splitting the data. So test size is 0.3. That means test data will be 30%, training data will be 70%, and the random set that we are having 40. Okay, so that what this test train split actually means is we'll be having a library for test train split. This function is the code set that we'll be performing to dividing our data on X and Y into testing and training data. So using for this, use like this X train and Y train is used for training model. Okay, for the model what we are doing will be used for training the model, and by X test and Y test using to evaluate and validate how well the model is performing. Okay, so X train and Y train used for model training. And when this X train and Y train, we are again performing for model evaluation. As X train and Y train data is already seen by the model will give 100% data, 100% accuracy. But whenever we give the data with unknown data that we're having, so for example, if we give it X test and Y test, the model didn't see this thing, so it will give some accuracy that will be real, like that will be equal, somewhat near to the realistic accuracy that we'll be having. And also this test set that we'll be having, this 0.3 means 30% of the data will be used for testing, and the remaining 70% is for training. So the random set 40 that we are having right now is like setting a seed for randomness. Okay, what are the randomness that we're having? We'll be giving that as 40. So it ensures that every time we run this code, it split the data exactly. Okay, so it will be splitting the data exactly, and this is crucial for reproducibility and comparing models fairly. Okay, then we'll be printing this thing. So how much is the shape of this X train and Y test that will be using this thing. So that's it for today, guys. We are past the time of the session. So we'll be getting to know about the models and everything in the next session. We'll be evaluating every model and we'll be seeing why we got an error here. Someplace we got an error, right? Let me just see this thing. Okay, you can see we have got an error here. We'll be seeing why we got an error and everything. So we are at X and Y train. I hope everyone understood this session today. So that's it for today, guys. We'll meet in the next session. And I want you to remember that the next session we'll be having is the last session. Okay. The next is the last session that we'll be having. So please make sure you'll be attending the session with most capacity. Around we're having all 30 participants. I want every participant to attend the session. Give me some response, everyone, so that I can end the session.